Physics Part 54. B. Find also the total distance travelled between t is equal to 0 and t is equal to 30 seconds. Note these figures refer to a case of not uniform acceleration, which is more realistic than the previous example. However, the same rules apply. The acceleration is given by the slope of the velocity minus time graph at the relevant time, and the distance travelled can be found from the area under the graph. Two-dimensional motion under a constant force. So far we have been dealing with motion along a straight line, that is, one-dimensional motion. We now think about motion of the particles moving in paths in two dimensions. We shall need to make use of the ideas we have already learned regarding vectors in Chapter 1. The particular example we shall take is where a particle moves in a plane under action of a constant force. An example is the motion of a ball thrown in an angle to the vertical, or an electron moving at an angle to an electric field. In the case of the ball, the constant force acting on it is its weight. For the electron, the constant force is the force provided by the electric field. This topic is often called projectile motion. Galileo first gave an accurate analysis of this motion. He did so by splitting the motion up into its vertical and horizontal components. And considering these separately, the key is that the two components can be considered independently. As an example, think about a particle sent off in a horizontal direction and the subject to a vertical gravitational force, its weight. As before, air resistance will be neglected. We will analyze the motion in terms of the horizontal and vertical components of velocity. The particle is projected at time t, which is equal to 0, at the origin of a system of x, y coordinates with velocity ux in the x direction. Think first about the particle's vertical motion in the y direction. Throughout the motion, it has an acceleration of g, acceleration of free fall in the y direction. The initial value of the vertical component of velocity is uy, which is equal to 0. The vertical component increases continuously under the uniform acceleration of g using v is equal to u plus at. Its value is vy. At a time t is given by vy is equal to gt. Also at time t, the vertical displacement of y downward is given by y is equal to half gt square. Now for the horizontal motion in the x direction, here the acceleration is 0, so the horizontal component of the velocity remains constant at uz. At time t, the horizontal displacement x is given by x is equal to uxt. To find the velocity of the particle at any time t, the two components vx and vy must be added vectorially. The direction of the resultant factor is the direction of the motion of the particle. The curve traced out by the particle subject to a constant force in one direction is a parabola. We've got a water jets from the garden sprinkle showing the parabola shaped spray. If the particle had been sent off with velocity u at an angle of theta to the horizontal as in the figure, the only difference to the analysis of the motion is that the initially component of the velocity is u sine theta as shown in the example.